So essentially how building automation systems work is that it automatically controls the building to save as much energy as possible, which also increases its effectiveness. It automatically communicates with other software and hardware within the building to correct issues and also maintain proper energy conditions throughout both the day and the night. And through my research, I found that these kinds of systems hardly encounter issues or failures because you're taking out that human error component, since they are all computer operated. And then by consistently monitoring and also controlling the environment within the building, it's preventing carbon dioxide emissions, and this makes it number 45 in the drawdown solutions textbook, in terms of its ranking. So I'm going to just show you guys this quick little clip that I found on YouTube, and I found that it was a good visualization of what these BAS systems look like and why we have them in the first place. So, here we go.
Human beings are sensitive to their physical environment, temperature, humidity, light, sound, and make every effort to exert control over that environment. Early on, humans employed fire for light and warmth, while natural shading offered relief from oppressive heat on summer days. As technology advanced, increasingly complex structures were built with associated systems to maintain comfortable environmental conditions. The modern era of buildings, beginning in the late 19th century, witnessed rapid advancements in mechanical and electrical systems specifically designed to maintain tenant comfort with little regard to energy efficiency and virtually none to environmental impacts. As energy prices rose in the 1970s, focus was placed on facility efficiency. Building owners and managers began to see the wisdom in applying newly available computer-based digital controls to the efficient management of energy-intensive heating, ventilating, and air conditioning (HVAC) systems. Thus began the field of building automation systems, BAS. Over the past 4 decades, since the 1970s, increasing awareness of environmental pollution and global warming has brought added attention to the important role BAS systems play in managing efficient buildings, the single largest energy-consuming sector of the U.S. economy. No longer limited to controlling just HVAC equipment, BAS systems have become the central nervous system of modern buildings, controlling virtually everything in a facility. The field of BAS rests at the intersection of traditional professions such as electrical work, HVAC, information technology.
Okay, I'm going to stop it right there and just continue with the presentation because it could go a little bit longer. Okay, so I also did want to mention that the benefits to having a BAS system within a commercial building compared to a traditional one. So first is that it's proven to be cost effective. It minimizes the damage to our environment, and it also reduces energy consumption. And then another one that I didn't put on the slide was that it reduces management and also infrastructure costs. And now moving on to the drawdown facts. So commercial buildings today account for 1/3 of global energy use and also 1/5 of our global greenhouse gas emissions. It's estimated that BAS can reduce energy consumption by 10 or even 20%. And it's also estimated that it can increase heating and cooling efficiency by 20%, which is huge. And BAS can even increase energy efficiency by 11.5% by regulating just the lights and appliances alone throughout the day. If BAS systems were implemented into 50% of commercial buildings today, it's estimated that it would cost $68 billion, but it would save building owners $881 billion in operating costs. So overall, this would prevent 4.6 gigatons of carbon dioxide emissions created in the first place. So now I just wanted to give you guys a quick little visual of what this might look like in comparison to something else. So I found this amazing website that basically let me put in like the gigatons, and then it created a picture for me. So this little blue mass is 4.6, where are you guys? 4.64 gigatons of carbon dioxide that could be prevented in relation to the Statue of Liberty. So you can see the mass and the volume. I mean, it's extensive. So now moving on to the barriers. So energy expenditures are usually a small cost driver for businesses. So that's going to be a barrier that a lot of businesses come to. So it's not the first place that people tend to go to when thinking of trying to reduce their costs. And then another barrier would be the relationship between a tenant and a landlord. So this is the case if let's say the building is not owned by the tenant. So if the landlord and the tenant are not working closely together, the incentive to maximize efficiency might not be taken as seriously. And this is basically because the landlord is the one that has to approve these building systems, but the tenant is the one that bears the cost. So a solution to this barrier is to push the need for tenant comfort with a BAS system in place that would help the landlord keep the tenant longer. So it's going to be a win-win situation for both in the long term. And then the biggest argument in favor of BAS is the fact that it's becoming a necessary system in order to meet both local and national efficiency requirements. So I just want to give you guys a couple examples of what building automation systems look like today. So first off, I want to start off with a company called Honeywell. They are Honeywell Connected Buildings, which last year they installed a BAS system at Hadman bin Mohammed University in Dubai. And within the first months of them using the system in their building, they saved 10% in energy use. And this was done by controlling the entire hardware and software of the building. And I did want to point out one quote that I saw from the VP of this company, and it says, "Buildings aren't static steel or concrete anymore. They're dynamic ecosystems, and their energy needs fluctuate based on ever-changing variables like weather and occupancy." So once again, it's kind of proving the fact that in order to be more efficient and to save our carbon emissions, we need to have a system that's controlled by computers and not by humans that make errors. And it needs to be a continual process. And then there's another company called Lucid, which is trying to implement the BAS systems into more buildings across our nation by introducing the smart technology into municipal buildings through the nation in collaboration with the Clinton Global Initiative. And now moving on to the skeptical science myth that I was assigned. So for today's, it's the fact or the idea that it's not urgent. So although some skeptical science although some climate change skeptics might argue that it's not that urgent, research has proved that it is, because global warming is an urgent issue that is only going to worsen if we don't get involved and we don't do something about it. So although we often don't see the direct impact of global warming right away, it doesn't mean that it doesn't exist. Often we don't see it because the effects of it are so delayed that we don't notice them. So climate researchers warn us that if we don't act now, we might get to a point where we're passing all the tipping points and we're going to spiral rapidly, and we're going to get to a place where Earth's climate is no longer what we are used to and what's healthy for us. So I did want to point out that NASA's top climatologist, James Hansen, reports that carbon dioxide is rising by 2 parts per million each year as we keep burning fossil fuels. And he also warns us that in order to stabilize Earth's climate, we must reduce our carbon dioxide to 350 parts per million as soon as possible. And right now we are currently producing 390 parts per million. So that's 40 parts per million past the safety level, the recommended safety level, which means that we have to do things rapidly in order to change the warming of our planet. And although our planet has only warmed, I believe it's 0.7 degrees Celsius, we have to realize that that number is deceptive because our global climate has not fully responded to our past emissions. So yes, it's only warmed up that much, but that's because that number doesn't account for our past that is still going to basically hurt us sometime soon. So in order to help prevent further warming, we must target the strongest and the fastest growing climate driver, which is carbon dioxide. In order to get back to 350 parts per million, which is the recommended safety level, we must phase out coal by 2030. We must stop burning tar sands. We have to avoid burning more oil. And we also have to implement more reforestation projects worldwide. So now moving on to the discussion questions. I wanted to see, do you guys think that implementing BAS systems should be required in all commercial buildings across the nation or even across the world? And then second, do you think that this could be something that even small businesses could benefit from? And then why? Third, does anyone see any barriers not listed that you can think of? And if you can't, then imagine that you're the CEO of a large firm. What would keep you from implementing a BAS system into your building? And then lastly, can you think of any green buildings in your area? And do they use BAS? Thank you guys, and have a great week.